Learn how to implement object-oriented programming concepts in the C language. While C is not an object-oriented language, we can implement OOP concepts using structs and function pointers. First, let's understand the core principles of object-oriented programming. Object-oriented programming has four main principles that guide its design. The four pillars are encapsulation, abstraction, inheritance, and polymorphism. C doesn't have built-in object-oriented features, but we can simulate them using structs and clever design patterns. Let's start with encapsulation, bundling data and functions together. In C, we use structs to group related data members together into a single unit. For example, a rectangle struct contains width and height as its data members. This struct encapsulates the rectangle's properties and can have associated functions to operate on this data. We can place function pointers inside structs to simulate methods that operate on the object's data. Now let's see how to create and initialize objects in C. We start with a basic struct definition containing the data members we need. This typedef struct defines a point with x and y coordinates. We create constructor-like functions to initialize our objects properly. The init function transforms an uninitialized struct into a properly initialized object. Function pointers let us attach methods to our objects. We declare function pointers as members of our struct to simulate object methods. This struct contains data and a method pointer that takes a pointer to the object its. Each function pointer in the object points to an actual function implementation. Inheritance can be simulated by embedding structs within other structs. We place the base struct as the first member of the derived struct to simulate inheritance. The derived struct contains all the base struct members plus additional members. By embedding the base struct first, we can safely cast between base and derived pointers. Polymorphism lets different objects respond differently to the same function call. We simulate virtual functions by storing function pointers in a table structure. Each object type has its own function pointer table, allowing different implementations of the same interface. Let's look at a practical example implementing a shape system in C. We create a base shape structure with a virtual draw function pointer. Shape is the base, with rectangle and circle as derived types, each implementing their own draw function. Rectangle and circle each have their own implementation of the draw function. Proper memory management is crucial for OOP in C. Constructor functions allocate memory and initialize objects, while destructor functions clean up. Objects are created with malloc and must be freed when no longer needed to prevent memory leaks. Let's consider the advantages and limitations of OOP in C. OOP patterns in C provide better code organization, modularity, and reusability. However, everything must be managed manually without compiler support or syntax sugar. While OOP in C offers benefits, it requires careful manual implementation and is more error-prone than native OOP languages. Let's recap the key concepts of object-oriented programming in C. We use structs to bundle data and function pointers together, simulating objects. Inheritance is achieved by embedding base structs as the first member of derived structs. Polymorphism works through function pointer tables that allow different implementations. Always remember that proper memory management with malloc and free is essential. While OOP in C requires discipline and careful design, it provides valuable structure for large projects.